Welcome and hello. This is a Heck HMS video exercise titled Reach Routing Comparison. What we're going to do in this exercise is use the Muskingum reach routing method and compare the routing results through a single reach with different values of K. K is a parameter used within the Muskingum reach routing method. All right, we're going to start from scratch here. And all I've done so far in my Heck HMS model is create a project. I'm utilizing version 4.13, so you're welcome to follow along. All right, so with my project right here, I'm going to start by adding a basin. Basin Model Manager, new Basin 1, that's fine. Here's the basin. I'll click on Basin, and I'm ready to add some elements. Let's start by adding a source creation. There it is, source creation tool. We'll just call it source-1. Let me click on the arrow so I can pan over. Next, what I'm going to do is have a reach down to a sink, and then that will be it for my entire network. What I'm doing here is creating a very simplified version of what could be a much larger network with multiple reaches, but I'm just going to build something fairly simple with a single reach. This is also not geo-referenced, so if you have your GIS data available, all of that could be utilized to create a more complex network of reaches. All right, so let's see. Next would be, how about let's do the sync next. So boom, there's the sync creation tool. Sync-1 is the name. That's fine. And then finally, the reach creation tool is right here. I'll just go single click and single click, call it reach-1 and create. I need to connect my elements together. So click on the arrow again. Source, I'll go right click, connect downstream, single left click on my reach. Okay. And if I wanted to reposition things, I can just boom, do that. Now to connect the reach to the sync, I'll right click on the reach, connect downstream, and single left click on the sync. Okay, so that's kind of stuck together there. This is it for my network. Next, what I want to do is add a meteorologic model. So we have the basin model, good to go so far. We are going to come back and modify the source and some of the reach parameters down here in the components menu, but we're going to come back to that a little bit later. All right, let's add the meteorologic model. Now, this particular project is a little bit different. We're not going to have any precipitation or transformation. I'm simply using this source as a source where I can route inflows into the source and then observe the behavior of the water through this reach and the difference between the inflow of the reach and the outflow at the reach between the source and the sink. So with that in mind, I'm going to create a meteorologic model, but it's really just a dummy placeholder within the model because Heck HMS simulation runs require a meteorologic model. Click on the components menu, meteorologic model, click on new, and then we could call it MET1, but just to be explicit, I'm going to call this no rain meteorologic model, and then click on create. And if we expand that, no rain, there it is. And I guess one more thing I need to do is click on basins and then basin 1, change the no to a yes, and click on save. All right, right now it's using specified hyetograph. That's really not too important to me because I'm not going to have any rain anyway. So we're just going to go ahead and leave it like that. Next, what we need to do is add a controlled specification. This is the duration of the start and end of the simulation. So components, control specification manager, click on new. Now, if you wanted to go straight to this dialog box, you could just go components, new component, control specification, and see, boom, same thing with the basin model, the MET model, and some of the other components that you can add, like data sets. Okay, so control 1 is fine. It's going to be our only control specification. Let's go ahead and edit some of the parameters here. Control 1. I'm going to run a simulation that runs on a 1-hour time step for the first 5 days of the year 2000. So to do that, the start date will be 01 Jan 2000. The start time is going to be 0 o'clock. That's the very beginning of the day. And then the end date is going to be 06 Jan 2000, also at the very beginning of the day. So through January 5th, but not January 6th is basically what that is. the time interval, I'm going to use a 1 hour time step, but if your data is different, then you would use obviously a different start and end date time as well as a different time interval. Okay, so we need to remember these numbers as well because we're going to be creating a time series data set that coincides with the same start and end date time that's going to be used as our input to source one. And we're going to do that right now. So I'm going to click on save and we're going to head over to DSS view. So fire that program up if you don't already have it ready to go. Here is my DSS view. I'm going to create a data file. So go file and then new. This is a DSS file. Navigate to the location on your computer where you want to save this file. Exercises right here. You'll just put it in here. Okay. Data, I'll call this data 2 and create. All right. So I've created my file. There's a little tab here that says data2.dss representing the file. So you can have multiple files open in the same interface. I've got a couple scripts here. Don't worry about those. And currently there's no paths in the selected file. Let's go ahead and just manually create a time series data set. I have some Excel data that I have ready to populate for the flows. So we'll get to that in just a moment. Data, manual time series. So then I can enter the path name parts individually, but on my clipboard, I have what I want to put. Just a generic project location. C is the flow for flow rate, and 1 hour is the time step. Now, remember back to our control specification, we need to input the same start and end date time. Of course, the data itself could extend past the control specification start and end date time, but I'm just going to make them the same. So January 2000, the start time is 0 o'clock. The units are going to be in CFS, and then the type, let's see. Yeah, we'll just go instantaneous value. Now I need to paste in my flow rates right here. So here is my data. I just made this data up, but you'll probably have some real data eventually. So I'm just going to put my cursor right here on the first time period and then click on the paste button and that pasted in. So there should be 121 records. I'll go ahead and click save and then check out what that data looks like. Here is a plot of that data. I can tell it's instantaneous values, not period average, but I may want to use period average. We'll just go with this for now. And then the actual numbers are right here. So those are the numbers that we pasted in. And these are the numbers. This is the time series data set, which we're going to create in HMS and then assign to our source one. So this is all good to go. I'm going to minimize it just in the off chance that I need to revisit that for some reason. Back in HMS, we'll click on Components, Time Series Data Manager. This is going to be a discharge gauge, so we'll click on New. And then how about we call this Inflow at Source-1 and create. Okay, so we can close that. Let's open up our time series data set. Let's expand our discharge gauges. Here's the discharge gauge that we just created, Inflow at Source-1. Down here in the components editor, I need to reference that DSS file and path. So let's go ahead and switch this to DSS view or DSS. And then the file name right here, for me to get the file selector, you kind of have to expand the width of the components editor and the Watershed Explorer so you can see these buttons right here. Or I guess you could just paste in the path directly, but it's sometimes easier to just navigate to that DSS file. HMS exercises. Okay, here's my project directory and data2.dss and click on select. All right, next row down right here, click on this button to select the path from that DSS file. Boom, here it is. This is the only path. Make sure to click on set path name. So that should be set right there. Grayed out for units of cubic meters per second in time interval. This is not what we're going to be using. What it's doing is it's going to read the units and the time interval from this path. So if I expand on the inflow at source one and then click on this time window, let's go ahead and set this to the time window we want. In fact, it's almost exactly what we want. We just got to make it 5 days instead of 1. Okay. And then if I click on table, this table data should be the exact same data from our Excel file and from the DSS view path. And then here is a graph of it. Okay, so let's click back on time series. Okay, and it looks like down here the units and time interval have updated to CFS and to 1 hour on our time step. Now it's time to actually assign that inflow data to our source one. So let's click on source one and then reach ones, the downstream. Here we are. So on the source tab for flow method, click on discharge gauge, and then click on the inflow tab right here. And then for the discharge gauge, select our one and only discharge gauge, which is labeled inflow at source one. Okay, so save that. We're good there. Next, we're going to update some of the components to the reach. So click on the reach. Let me give myself a little more room here. So for the reach tab, we have lag as the routing method. Obviously, there's a lot of different routing methods. For this exercise, I'm going to just work with the Muskingum routing method. There's also loss and gain method. I'm not going to deal with that for this exercise, but certainly something you may want to consider for your model. All right, and then click on the routing tab. Now, for the Muskingum K value, this first time I'm just going to say 5 hours. And then Muskingum X, I'm going to just make up 0.25, and the number of subreaches, we'll just leave it at the default value here of 1. All right, so that should be it. I don't think there's anything else we need to do before creating a simulation and running it. So let's save that. Click on Compute, Simulation Run Manager. Click on New. We'll just call it Run 1 for now. Click on Next. Now we need to specify the basin, the MET model, and the control specification. So basin 1's our only basin model. No rain is the name of our only MET model, and control 1 is the name of our only control specification. All right, simple enough. Let's go ahead and select that simulation run and run it. So that looks good. No error messages down here in the console. Let's go ahead and take a look at some of the results. So right click on the reach within the basin model, view, and then graph. So the colors here are both blue. I'm going to modify that real quick. Edit plot properties. And then so this is the inflow right here. I'm going to make this solid, and then let's make it blue. How about that thickness? And then this series of data is the outflow from the reach. Let's make that solid. Let's change the color. How about red? And then let's make it that thickness. Apply and OK. All right. So this is the inflow and outflow through that reach based on our given inflow data and the Muskingum routing parameters. Blue right here, I've highlighted the inflow, looks a little bit more sporadic and jagged, whereas the red right here, the outflow, looks a little bit more smoothed out. I can click on the magnifying glass and zoom in some more if I want. And then I can, of course, pan across, pan up and down. I don't think it's any surprise that there does seem to be a lag, meaning that the red line, the outflow, more or less lags the blue line, which is the inflow. If we're interested in the actual numbers themselves, we can go up to File, Tabulate, and I think it opened up behind here. Yeah, here it is. So what we're looking at here is the inflow data and the outflow data. And this is a 1 hour time step. So let's go ahead and mix things up here. This is with a Muskingum K value of 5 hours. Remember when we clicked on and defined the reach properties right here, Muskingum K, 5 hours. What I want to do for the last part of this exercise is change this Muskingum K value to a different time period, a different duration, and then compare the inflow with the 5 hour and then our second option, which let's go ahead and make it 10 hours. So we're going to double the value here, but we're going to keep the Muskingum X value the same, as well as the number of subreaches stays at 1. Okay, so to do that and to sort of keep our data organized, I'm not just going to change this to a 10. What I like to do instead is make a copy of this basin and then call this basin, say, A equals 5 hours, just for comparison purposes. That would be helpful because the K value is going to be the only difference between both our two basin models and our two simulation runs. All right, so let's start with saving everything first. I'm going to right click on basin 1, click on rename basin. I'm going to call this K equals 5 hours, then enter. Now what I'm going to do is create a copy of this basin model. So right click, create copy, and then for the new name, I'm going to call it about 10 hour, A equals 10 hour, and copy. I'm going to click on A equals 10 hour basin, and then click on the reach. Of course, it's using Muskingum method with no loss or gain, but click on routing, and then I'm going to change this 5 to a 10, and tab off and save. So that's the only change we need to make to be ready to rock and roll with our K equals 10-hour basin. The other thing we need to do is create a new simulation run, which utilizes this basin that has a twice as long K equals 10-hour value for the Muskingum K parameter. So to do that, I'm going to go up to Compute, Simulation Run Manager. I'm also going to rename the Run 1 simulation to something a little bit more meaningful for us. Now that we have 2 simulation runs, getting the naming right could be more helpful for us moving forward. So I'm going to select Run 1, click on Rename, and I'm going to call this K equals 5 hours and rename. Now what I'm going to do is select that simulation run, click on Copy. It's asking for what is the name of the new simulation run, K equals 10 hours, and copy. And what I want to do is edit this K equals 10 hour simulation run, click on Edit, and then I need to change the basin model from 5 hour to 10 hours and apply. Close and close. Now, one last thing we need to do before running the 10-hour simulation is to click on the no rain model, and then we want to select basins and make sure that the 10-hour basin is used by this MET model. So that's done. Let's go ahead and run the 10-hour simulation, K equals 10 hour. So run, and that finished. Very quick and easy. And let's take a look at our results. So I'm going to come right here to the Results tab, expand simulation runs. Now I notice K equals 5 hours is grayed out. I think that's because we renamed it. So let me go ahead and just rerun that real quick. And then we should have some results to look at for both simulation runs. And it looks like that is the case. So I'm going to expand both simulation runs. I'm going to expand the reach one within both simulation runs. And then I want to click on Outflow for the 10 hour, hold down Control, Outflow for the 5 hour, and then also hold down Control, click on Combined Inflow. Next, I'm going to come up to the Graph button right here. So this is all 3 series, the inflow, and then both outflows for K equals 5 hours and 10 hours. I'm going to update the plot properties again and apply. Okay, off camera, I updated the plot properties. We have blue as the inflow. Red is the K equals 5 hours, and green is the K equals 10 hours. So if you can't see it, here's the blue, that's inflow. Here's the outflow, K equals 5 hours, and then double the delay, or double the K value at least, is right here in green, K equals in hours. Okay, so that's just a 1 hour time step we were using. Again, we can go up to File and Tabulate. Okay, cool. Again, here is the inflow, here's the 5 hour outflow data, and the K equals 10 hour outflow data. All right, so there's that. Some final thoughts on this exercise. If you wanted to expand your model beyond just one reach, that's certainly an option, which could add a lot more variety and area for analysis. Something else you could do is go to the reach data or to any of the nodes and add in the options tab some observed data right here. This isn't something I have, but it's something that could obviously allow you to calibrate and validate your model and the specific parameters that you're using based on the routing method that you selected. Another idea I had was change the routing method. So we selected Muskingum routing, which is right here in reach, but you could obviously select a different routing method. So for instance, if you selected normal depth and then clicked on the routing tab, you have a lot more parameters to work with, such as the slope, the Manning's end value, the shape of the actual channel. So you could select 8 point, for instance, and then define the cross section right here, which would require you to go up to the components menu, paired data manager, and then you'd click on cross sections, new, and then give it a name. I'm not going to do that right now, but it would pop up down here, not under time series, but under paired data sets. And then you would ultimately navigate to a paired data set you could create in your DSS view. Or there's also manual input options on these data sets. Last couple ideas I had were if you actually had a terrain model, you could use the GIS tools and georeferencing and then run some computations to actually get the values for your slope, for your length of the reaches, and so on. We were using Muskingum routing, so we kind of got away from some of those details. And my last idea was that HMS is just one model that could you can use to calibrate some of your reach calculations. So for instance, I'm personally familiar with HEC-RAS, but that's just one of many different models that includes reach routing, which you could use to solve your hydrologic problems. All right, well, that's it for this exercise where we involved reach routing comparison in HEC HMS.